Good morning, my dear students. Welcome to KGBV online classes. My name is E. Mahalakshmi, working as Physical Science CRT in KGBV Vajrakarur, Anantapur district. How are you, students? I think all are fine. Nowadays, we are facing a pandemic situation called COVID-19 with great effort. For that, you are staying still at home. So, children, stay home and stay safe. Don't go anywhere. Today, I am going to discuss 10th class 3rd chapter, Refraction of Light at Plane Surfaces. Okay, children? I will ask some questions. What is the reason behind the formation of mirages? What is the reason behind the shining of diamond? To answer these questions, we need to know about total internal reflection. So, today's session about total internal reflection. By doing an activity, we know about a critical angle and a total internal reflection. For this activity, we need a plank covered by white chart, semicircular glass slab, circular protractor, and laser light. Take a wooden plank which is covered with white chart. Draw two perpendicular lines passing through the middle of the paper. Mark horizontal line as MM while vertical line as NN. Horizontal line as MM, vertical line as NN. Draw a circle and mark angles from 0 to 90 degrees in 4 quarters of the circle by using a circular protractor. Now place a semicircular glass slab so that its diameter coincides with the line MM. Semicircular glass slab diameter coincides with the line MM. Here glass slab is a denser medium and air is rarer medium. Here glass slab is denser medium and air is rarer medium. And MM is a interface of two mediums. MM is interface of two mediums and NN is normal. When we send laser light to glass slab, it bends away from the normal. When we send laser light to glass slab, it bends away from the normal. It travels from denser medium to rarer medium. Light rays travels from denser medium to rarer medium. At the same time, some part of light reflected to the glass slab. When light ray passes through the normal, does not deviate. When light ray passes through the normal, it does not deviate. When light passes at 10 degrees, it's refracted at 15 degrees. Here, some part of light reflected 10 degrees. Here, incident angle is 10 degrees, refracted angle is 15 degrees. Reflect angle is 10 degrees. When light passes at 20 degrees, it's refracted at 30 degrees. Here incident angle is 20 degrees, refracted angle is 30 degrees. Here also some part of light reflected 20 degrees. When light passes at 30 degrees, it's refracted at 50 degrees. So, here incident angle is 30 degrees, refracted angle is 50 degrees. When light passes at 40 degrees, it's refracted at 80 degrees. We will observe that at a certain angle of incidence, the refracted ray does not come out. Some certain angle of incidence, the refracted ray does not come out, but grazes the interface separating air and glass. Now, we measure the angle of incidence to this situation. This angle of incidence is known as critical angle. This angle of incidence is known as critical angle. Let C be the critical angle, then R becomes 90 degrees. Here R means refracted angle. From Snell's law, we get n1 by n2 equals to sin 90 by sin c. This implies n1 by n2 equals to sin 90 value is 1. So, 1 by sin c. We get sin c equals to n2 by n1. We know already n1 by n2 equals to n12. That is, n12 is called refractive index of a denser medium with respect to rarer medium. n12 is called refractive index of denser medium with respect to the rarer medium. Sin c equals to 1 by n12. This is a critical angle. When the angle of the incidence is greater than critical angle, the light ray gets reflected into the denser medium at the interface. That is, light never enters the rarer medium. When the angle of incidence is greater than critical angle, the light ray gets reflected into the denser medium at the interface. That is, light never enters the rarer medium. This phenomena is called total internal reflection. This phenomena is called total internal reflection. Now, we are going to understand the reason for brilliance of diamond and about mirages. So, the reason for brilliance of diamond is the critical angle of diamond is very low, that is 24.4 degrees. So, if a light ray enters a diamond, so if a light ray enters a diamond, it is very likely to undergo total internal reflection, which makes the diamond shine. Do you know about the mirages? Mirages is an optical illusion where it appears that water has collected on the road at a distant place, but when we get there, we don't find any water. We don't find any water. So, this is a example of a total internal reflection. Okay, thank you students.